Hey guys, so this is the new toy that I got. This is a scope. It's from Hitachi. It's a 35 megahertz V352F scope. You know, it's pretty average. It's missing a few things, but it's pretty nice. Better than the cheap little digital scope that I had before. So I'm basically going to go through each of the controls, tell you what they do, show you how to use them. This is the power knob. So if it's off right now, you know, it's not going to display anything. You can turn it on, and there's a little LED indicator that comes on above it. See right there. If I turn it off, LED goes off. I turn it on, and you can see that we can turn the intensity way up to the top or down to the bottom. You want the intensity about there, right? You don't want it to have super intensity. You don't want really bright intensity, otherwise it'll burn your screen. So you want some average intensity. Now the focus, right? A badly focused beam is bad. You want to get that beam as sharp as you can. That's a nice sharp trace right there. Right? This trace rotation knob, you do that in case your trace is rotated one way or the other. Scale illumination knob basically just lights up the grid. That doesn't show up too well on camera, but not quite the best knob to use. So now, to explain the basic function of the scope, which is what I'm going to need to do, explain how a scope works, to explain to you how to use the controls, there's this knob that says time per division. So if we go right down there and turn our intensity down a bit so we don't burn our screen, you can see that there is a dot being swept across the screen, right? And you want to make sure that all these red knobs, these are your cal knobs, are twisted to their position. If you see, I'm going to zoom in on it. You see there's the cal position there, and then I'm not sure you can see that, but right there on my fingernail there's a little notch. You want to line that up with the cal position. In the case for all my cal knobs, it's all the way to the right, but you're just going to want to play with that. Over to our time-based knob, you can see that right now I've set it on 0.2 seconds per division. So remember that. So when we go to look at the screen, this dot is basically going across each division. It takes 0.2 seconds for the dot to go across the division. Okay? So now if I crank the time base up to 0.1, you're going to see the dot is going to go faster. It's going to take 0.1 seconds for the dot to go across the division, right? And if we count the divisions, 1, 2, 3, 4, 5 division to the half, there's 10 divisions all the way, so it's taking this exactly 1 second to go across all the way. Right? So you can see, this isn't, you're going to say, well, if I hook it up to a signal, it's going to take me a full second to actually see the whole signal. So, you know, that's not great. But look what happens when you turn it up. Persistence of vision will, you yourself have persistence of vision. So you are going to actually see the dot move across, and your eyes are going to persist the dot, basically continue to see the dot after it's not there. The phosphor in the screen also has persistence of vision, in that it will continue to display the dot after the electrons have stopped hitting it. So both those persistence of visions combine to be able to show you a nice clean line that can be varied by your signal. So if you see, when we twist the knob all the way down, right, we have to change our horizontal position, which I'll go over, but it gets dimmer, you see. If we turn it up, it gets much brighter. Right? This is because it's taking the dot longer to sweep across. It's sweeping across the screen faster, so less electrons get to hit the screen, so it's dimmer. So if you turn your time base up, just be wary, you might have to turn your intensity up as well. I was talking about this horizontal position knob earlier, so I'm going to zoom out and show you what it does. Okay, so you see this line has the position on the screen horizontally, right? So we can vary it like this. Now, normally what you want to do is take this, and you see the edge of the trace right there, and you're going to want to put it right to the edge of the screen from where you're viewing it. This is going to let you see the rising edge of the signal that you're viewing, and you're going to see most of the signal. Now for some reason, if you need to see the beginning of the signal more clearly, you can set it like this, and you're going to be able to see exactly where your scope is triggering on the signal. But for most of the time, you're just going to put it like that. So now that we've gone through all the basic controls, and you've seen how the time base works, right, there's also this XY position that's going to get you something like that, but just stay away from the XY position for now, right? And you can see that sometimes the persistence of vision and the phosphor in your vision is not enough to actually create a line, so it's sort of blinky like that, or blinky like that, or flickering a bit for me like that. And then there's this, and, you know, it can get like that, right? So this is where you're actually going to connect the signal. is right here to this input circuitry. So you have a couple of things, a AC, ground, and DC coupling switch. Ground coupling basically means the line on the screen is showing where the ground is. So if we zoom out here, our position, since we have it to ground switch, we are basically saying where ground is on our circuit. So if you're viewing a DC signal, you may want to set ground to the very bottom. If you're viewing an AC signal, you may want to set ground here. Or if you're viewing a signal with a large offset, you may want to set it to below the screen. This is all just personal preference and depends on the signal you're viewing. You will get the hang of it. Okay, so the switch, right? What does DC mean? DC means that the scope is connected to your input signal by a wire. So all parts of your input signal will get through to the scope. Now, this may sound like, why would you ever want to use anything else? But I will explain. This DC signal, say you have a signal that has a 5-volt offset, right? But the actual signal itself is very small. You can set your thing to 1 volt per division to have your signal display 5 divisions up. But if your signal is too small to be seen at 1 volt per division, you can see little, just very small variations in the trace, and you're not going to be able to see your signal. So that's no good, right? So you want to set it, in that case, to AC coupling. This is only going to couple the AC part of your signal, which is about above 2 Hertz or so, into your scope. Then you can turn this knob down, and it will be able to display the smaller instances in your signal. So I'm going to explain this knob now, right? This knob is your volts per division. So it's basically going to show how many volts a division represents on the vertical axis. So if we set it to 5 here, it's going to represent 5 volts per division. And since there is 8 divisions vertical, which is pretty standard, it could represent 40 volts peak to peak on your screen just fine, right? But you better make sure that your scope can handle that much voltage. And you can switch it all the way down to 5 millivolts, right? And then I've explained the cal knob before. You just want to hit that, put it to the cal position. And this, I don't think there's anything more I need to say about the vertical volts per division knob. It's pretty simple. This position knob, though, has an extended function. You can actually pull it, and you can get 5 times gain on your signal. So that means that, say you had it set to 1 volt per division for simplicity, right? And you pull it out. You're getting times 5 gain on that signal now. Right? So if we set it to 0.5, it's actually 0.5 times 5, or 0.1. Right? If you set it to 1, it's going to be 0.2. So it's just going to basically, make smaller signals easier to view, right? So this thing can only go down to 5 millivolts, but with this knob pulled out, it's actually 1 millivolt. Push it in, it's 5 millivolts, pull it out, it's 1 millivolt. So you can basically set that. So if you have it set to 1, it's going to be 0.2. If you have it set to 0.5, it's going to be 0.1, and so on, right? So that's a neat way to view smaller signals. Now when you pull out that magnification, beware your bandwidth drops a lot. You're going to have a lot less bandwidth. Bandwidth is basically the amount of, once your signal reaches just slightly below that bandwidth, it'll start to get attenuated, meaning the amplitude will drop. So because I have a 35 megahertz bandwidth, doesn't mean that I can't see signals of 40 megahertz, it just means they'll be reduced in amplitude. It also means that signals like starting from about 33 megahertz will start to get reduced in amplitude very slightly. But it's no big deal. So you can easily measure a 40 megahertz signal on a 35 megahertz scope. Just beware that what you're seeing on the screen, the amplitude isn't going to be the exact amplitude of your signal. The vertical controls are duplicated for channel 2. Exact same thing, AC, ground, DC, volts per division, cal, position. There's this input thing, which I had explained earlier. But basically, this is where you plug in your probe. So your probe's going to have a BNC jack on one end, and you're going to line up the slots in your BNC jack with a little knob things on the side and plug it in, and now it's in, and you have your probe here. Your probe is how you connect your scope to your circuit. So you either have this clippy thing, which you can clip onto a wire, and it's going to just grab onto it and hold it, or you have this tip, which you can just touch to your circuit to measure it, right? Be aware that this metal part here is ground, so you don't want to short the two together on your circuit. Now, most of the time you're going to connect ground using this ground clip, not the ground right there. If you connect it using this ground clip, you don't have to worry about ground, and if you connect it using this clip, you don't have to worry about anything at all. So that's how to plug in your probe. Now this mode switch really says, what are we displaying on the screen? Channel 1, as you can see in the top position, means we're just displaying channel 1, nothing else. Channel 2 means we're just displaying channel 2. Ignore the XY thing. I'm not even going to get into XY in this video. You don't need it. For now, at least. If you need it, then you should find somewhere else. So channel 2 is going to just display channel 2, not channel 1. Dual is going to display them both at the same time. As you can see, they're both on the screen at the same time. Add is going to basically add the two signals together, so channel 1 plus channel 2. And diff is going to take channel 1 minus channel 2. So, that's not too bad. Here is your trigger controls. So, these controls are really the most complicated controls on a scope, at least an analog scope. There is other, my scope doesn't have a hold-off control, so I can't tell you how that works, but you can look at the EV blog. Dave has a great video on the hold-off control you can use. But really, the trigger controls are probably why you're not getting a great view on your scope, right? It's pretty easy to set up your time per division knob and your volts per division knob, but without a good trigger, you're going to get garbage. What exactly is a trigger? So you're going to have to, I'm going to have to show you an example for this to explain it. It's rather difficult to explain, at least in my view. So I'm going to just plug something into channel 1, right? Plug the signal into channel 1, and I'm going to hook it up to the probe cal. Now it says the probe cal is 0.5 volts, so we're going to set it to AC because this is an AC signal here. And we're going to set our, since these are usually 1 kilohertz signal, we can set it to 1 millisecond per division. And you can see that the signal is 1 second, is 1 division, because it's rising right there, and it's rising again a division later. Okay? So, you know, we can get it like that, make it easier to view, make it more divisions, fewer divisions, right? So, now, it's displaying like this because I have a stable trigger. If I have an unstable trigger, you see I've just spun that knob. You see, just by spinning this trigger knob, I can get garbage like this or a nice clean signal like this. Now, you don't want garbage, you want clean signal, right? So how do you get a clean signal on a scope with your trigger? Well, one, you want to make sure your source, right here, you want to make sure your source is set to wherever you're triggering from. So it has 4 options. Channel 1 means it's going to connect the trigger circuitry to channel 1. So you're going to be triggering off the signal that's on channel 1. Channel 2 means you're going to be triggering on the signal that's on channel 2. So if you're, you know, but you can't trigger on both at once, keep that in mind. So if you're viewing a signal that's on channel 2, then you're probably going to want to set this to channel 2. If it's on channel 1, you're going to want to set this to channel 1. Right? So 99% of the time you want it on one of these settings, right? So chances are, if you're not getting a good trigger, perhaps you're viewing your signal on, perhaps you've set this switch to channel 1, but you're actually viewing a signal on channel 2. That would cause a bad trigger. So you'd set it to channel 2 in that case. Line basically means it's triggering off the AC line. So every 16.7 or something milliseconds, if I remember correctly, but 60 hertz basically. So this is great for seeing noise and stuff, but not very useful other times. And external basically means you can plug in a separate probe to this external jack here, this trigger input jack, and you can actually connect a third signal to your scope to trigger off. So you can be viewing 2 different signals at once with that dual knob on the mode we talked about, and you can trigger those 2 signals off of a third signal that's coming from your circuit. So it's very powerful, but very few occasions that I've found where it needs to be used, because most of the time you want your, you know, what's on your screen to be stable. So in my case, we're going to be connecting our signal to channel 1. So if we get the trigger circuitry and the screen in on the same time, then we reconnect our probe cal signal, right? You see this is garbage. Now, some people may not display anything on their screen because of this normal knob, right? So if you want to just see something on your screen, set it to auto. Don't worry about TV plus or TV minus, right? They don't really do anything. So those are unless you're working on TV signals, that is. So basically what auto does is it's always going to sweep the trace across, whether it has a trigger or not. Normal is only going to sweep the trace across if it has a trigger. So if it doesn't have a trigger, you're going to see nothing like right now. Right? We can see it doesn't have a trigger because it's jittery. So this is a good way to find out if you have a trigger or not. If you switch to normal and nothing's displayed, you don't have a trigger. Right? So this level knob, this is much better explained on a triangle wave. So I will disconnect the probe cal signal. and put this onto a triangle wave. Pardon if something like that happens, because I have to actually hold the probe onto the signal, because it's a banana jack, so I don't have any BNC to banana connectors. So if I let go of the probe for a second or it slips out of my hand, just bear with me. Okay? So what I've done here is set the horizontal position, so you can see that the edge isn't past the edge of the screen. That the edge is actually right now in the middle of the screen. This is going to let you see right here where it begins is where the trigger starts. So the trigger, basically the trigger, right, the signal as you're viewing it on this edge is right where it triggers. So you see we have our trigger set below, right? We're setting auto. So you can see we don't have triggers. We switch it to normal, there's nothing. So we have our trigger set to a positive slope, which is what happens when it's set in. And if we turn it up, you're going to see that I disconnected my signal. Okay. That right there, this is the lowest it would possibly accept a trigger. Right? That means it's, so when the trigger is set to this level, and on, we'll switch it to normal now because we actually have a trigger. So a trigger basically says display the signal only when it is going right now, in this case up through the level that is right there. So if we turn this level up, you're going to see it's only going to trigger when the level happens to be, you can see right now that our level is there. Now our level is in the middle, now our level is at that division, now our level is at that division and that division. Right? And if we pull it out, you can see the same is true in the reverse, is that only one is going down through that level. Right? So if you had a digital scope or a digitizing scope, it could actually get it to display that level. But, in this case, you can just vary your level. So you see this negative slope, it's when it's going down through that level, it's when it's going up through that level. So if we set our horizontal position back to normal again, here's another neat feature that you can have, is this mag knob, right? This is normally the horizontal position knob, but if you pull it out, it actually magnifies your signal. So you have to turn the intensity a bit up for this. But it's actually, you see that little thing, that little spike right there? If we pull it out, oh sorry, this mag knob is a bit jerky. You can see it's magnified the time base by times 10. So now you can actually see the full signal times 10 magnified, and we can actually get those little things. And we can see that my signal's a little jittery, but they're about half a division. Right? So, and we can actually scroll through the whole signal that we're triggering on with a times 10 mag view. So if we switch it, oh yeah, my trigger's not the best, guys, sorry, but you see it's like that, and now if we pull it out, it's magnified that by times 10. So that's really a neat control that you can use to do, and if you're setting right the mag, you may want to turn your intensity a bit up, because the mag is pretty demanding for that, right? You can see now we've lost our trigger, so if we get our trigger back on, sorry, that jittering is due to me letting go of the signal and the bad signal. So anyway, that's what a trigger is. It's very simple, and that is really how to use a scope. It's very simple. So thank you for watching.